Okay, so in this question, part number 2, part A, they want to see your integration technique and they want to see your partial fractions as part of the 3 marks. I think the answer and these 2 bits are going to be the 3 marks that you need. So while it's tech allowed, we do need to stage it a little bit. So I'm going to recognise that I've got P here and I've got a dP on the top, so I'm going to turn it upside down. Equals 1 on R, 1 on P, and 1 on 1 minus P on 30,000. And if I do fraction 1, and in the denominator do another fraction and do 1 minus fraction x on 30,000, didn't need that, so for one on the bottom, and simplify the answer, I get that. Now I'm not going to swap it around, so it's going to equal 1 on R times 1 on P times 30,000 on 30,000 minus P. It only supports 30,000 butterflies. I start with 500. I don't want to swap it around to say x minus 30,000 because that will always be negative if that's the case. So I'd like to leave it in that form. Okay. I'm going to let the examiner know that using partial fractions that times fraction 1 on x, and if I select it, interactive, transform, expand partial fractions, variable x, okay, that's what it equals. That equals 1 on P minus plus 1 on 30,000 minus P. So my T should equal the integral . 1 on R, 1 on P, plus 1 on 30,000 minus P dP. So I might take this and I'm going to interactive calculation integral with respect to x, okay, and that says T equals 1 on R log by C of P minus log by C of 30,000 minus P. Plus some constant C, which means that T equals 1 on R log by C of P over 30,000 minus P plus some constant C. I need to find out C, so if I go T equals 0, P equals 500, which is what we had, then what I can do here is I can say plus y equals 0 given x equals 500. And I'm going to get rid of the modulus and just write x. I'm going to get rid of the modulus and write 30,000 minus x and solve for y. And that tells me that C equals log by C of 59. which means t equals 1 on r log base c of 59, so that will be 59p on 30,000 minus p. So I've got so I would have RT to the power of E equals 59 on P, 30,000 minus P. So that equals E to the RT, so ZX, not X, Y. So X is my P, so interactive advanced solve for X. So there we have P equals 30,000 e to the RT over e to the RT plus 59. If you wanted to rewrite it, you could divide everything by this, which gives you 30,000. That divided by that is 1 plus 59e to the minus RT. Either of those are forms. So what have I done? I have shown the integration technique because I went from here to here integrating. I've shown the partial fractions because they had to ask me to do it, and I've solved it in terms of P.